Okay, now that I've loaded in my G-code, I'm going to do a number of tests. Namely, at least 3 tests is what's always recommended. You want to do one test that just is a cold run where you don't have the hot wire on and you're not cutting anything, just to see where the tool path is going to go and make sure that the carriages do not reach any of their extreme ends, or that you're going to try to cut into the sacrificial foam. Because again, if you're doing that, then you can probably redesign how you're going to be cutting your wing out of your block of foam better than you currently are doing. The second test that we're going to do is a quick hot test where we don't cut out the full wing, but just on a thin cross section to see that the airfoil's geometry is going to come out about how we want it to be, the spars will be where we want them to be, and that the temperature settings are correct. The final test, but the final cut will be for actually cutting out the wing when we are done. So coming back to the first test, now that we've zeroed our foam cutters to where the initial home position is going to be, all we need to do from here is note that we have all of the G-code set up starting here on the left-hand side. We should be on the very first row of code. And if we hit cycle start, then it'll start stepping through all those and moving the foam cutters through the path that we want to go. I often find it useful to lay down a ruler or something like that to also kind of visually see how far out it's going and if it's cutting about the cord length that you expect. So one thing that before we get started on that, we want to make sure to keep in mind that we know where the stop button is. The stop button is different than the reset button. The stop button is what we want to press if anything is wrong. That's where we're going to click to make sure the stepper motors stop moving and then we don't break anything. So I'm going to go ahead and click on that, but before I do, I'm just going to prematurely move this over here. And press cycle start. Now, depending on the settings of what you have built into your code, one thing that'll do is it'll move the hot wire cutter up and down a few times to give you time to heat up the wire. We control whether or not the wire is hot manually with another switch, so it does not turn on automatically. So it's not often a good idea to turn on the hot wire before you start cutting, just to give it time to heat up anyways. But this, the purpose of this is so that it will give time for the hot wire to heat up. Now as it moves into it, currently my code is set up on this particular run that it moves over the top of where my foam is and it's going to cut down into my foam to cut out a spar hole. So here I might measure really quickly how high up it was and if it's going to actually be over my foam block. I can also kind of throw a quick ruler under there to measure that it's going to be about 11 centimeters or so up into my foam, and I will know where it's going to try to cut out that spar hole. So I can see from this test run that it's nowhere near any of the limits of the carriages. We've got plenty of space on all the sides, so we're not going to try to run into things and ruin the stepper motors. The wire's not being strained in any way, and it will start cutting in the proper places and the proper lengths for all of my geometry. Normally you're going to want to let this run all the way through so that you can make sure that all of the limits are appropriate. For the sake of this demonstration, to save on time, I'm going to demonstrate how if something goes wrong, how you'd want to stop it prematurely. So if the hot wire is on, the first thing is always to turn off the hot wire. Make sure the hot wire is off so you don't burn anyone. But just as quickly, you need to run over here and click on that stop button so it stops trying to step through the G-code. If you turn off the hot wire first, but leave this running, the hot wire will cool off really quickly and start dragging through the foam, and it will actually break the wire and cause even more damage to either your part or surrounding materials. So typically, as fast as you can, you want to both stop the code as well as turn off the hot wire at the same time. I'm going to go ahead and hit stop. It's going to stop somewhere in the middle of my code. I'm going to click on rewind, which is this button right here. It rewinds the G-code back to the original start so that it can start cutting the profile over again. But we also need to make sure that our wire is now back to our home location. We've already zeroed it, so you just need to click on the Go to Zero button and it should go there. Again, I'm going to demonstrate that because it moves 3 of the axes first and then the 4th, we're going to use the arrow keys to get it close to 0, kind of eyeballing different things. And then as long as it's close to 0, you're not going to overextend the wire, strain things, and so you are safe to go ahead and click go to 0. So I find this one, because I have the taper ratio thrown in there, was out much further than the rest of my axes. So it's good that I use the arrow keys in order to get that close to where the home location is. Click go to 0 to have that finish up for me. It does 3 and then the 4th. And then now I'm set up and ready to go for my next test. Again, the next test will be a hot test, but it will not be for cutting our actual airfoil. It will be getting a general sense for the geometry of our wing. So zooming out here. Also, I should note that the left computer controls the left foam cutter and the right computer controls the right foam cutter. Likewise, we've got 2 power supplies. There's this power supply right here, the left one for the left foam cutter, and we've got the power supply on the right for the right foam cutter. The power strip just gives power to the stepper motors as well as to these power supplies. So you can't turn it on if the power strip is off, but always, always, always make sure that these power supplies are off, because that is what will be supplying the heat to the wire, and we don't want to either overstress the wire by leaving it on high temperature for long periods of time, or have it be dangerous where someone doesn't realize that the hot wire is on and actually burn someone. So that is always going to be off unless I am at the very moment when I'm ready to begin cutting something. So I'm leaving that off for the time period. I'm turning over here to the cutters. And again, we're not cutting out our entire airfoil, we're doing a test run to get a sense for the geometry. So what I have here is a piece of foam that is definitely not thick enough for any airfoil, but it is going to be long enough and it'll be tall enough to simulate my piece of foam. So it is a little bit too tall for the spar to go in the top, so I'm just going to break off the top there so that it gets roughly to the height of my foam. And I'm going to set this up lengthwise on here so that it'll cut out the profile of my airfoil, even though it won't be as wide as the length of my panel. It's often also helpful to put weights on either side of your big piece of foam, so that as the foam cutter is moving through it, it's not going to try to knock it over. So I just have 2 weights there that are pinching the 2 sides. They're far enough down that they should be out of the way of my airfoil, but I'll be keeping an eye on that to make sure that I don't accidentally run the wire into the weights and start breaking the wire. Now that everything is set up there, I'm just in the same way going to come back over to here to the computer, double check that I've zeroed the wire. Both here I should say all zeros, and over there I should see the wires at the home location where I wanted to start. I should see that my G code is at the very first line and ready to go. So I'm ready to click on cycle start. Now that I'm ready to actually cut something, I'm going to turn on my power supply. For most cases, the power supply should be set to the temperature that is appropriate for the foam that we use, so that should not need to be adjusted. If you do happen to find that you do need to adjust the temperature, just very small changes in voltage will create very large changes in the surface finish of your airfoil. So again, be careful with that. At no time do you ever want to be dragging the wire through your foam, so if ever a case happens to where it is dragging, make sure to either turn up the voltage or better yet, just simply stop your run and fix that first. So I'm going to go ahead and hit cycle start. My wire is on. I've given it some time as well to heat up while I was talking to you, but it'll also move up and down to give the wire a little bit of extra time to heat up. It doesn't take very long, just takes a few seconds, but the longer it is, the more consistent your cut is going to be. You won't have an unknown of a transient state of the wire heating up. So here, now that that's running, we're going to come back over to our wire. We noticed a little bit of fumes coming off of the wires. It's burning off some residue from previous cuts. Note that the fumes from this foam, as it's burned, are not bio-friendly. They are known some foams to be cancerous. That's why the fan for the fume hood is always on. Just make sure that as you're cutting this, that you're not leaning over the top of it, breathing in those fumes. Make sure you're being safe in all things. So here, I'm stressing the wire because I did not break it down low enough. I noticed that the wire was stretching a little bit too far, so it was moving too fast, thinking it was going over the top of my phone. So I moved my foam block so it wouldn't stress that. It's going to cut that out. Normally that'd be cause for maybe just redoing it, but because this is just a test case, I'm going to note that my spar hole will not be at the proper location for the airfoil I'm trying to cut. So now here it's moving backwards, trying to exit out of the foam. I'm going to move my foam back to my original start position. The wire's going to exit right there appropriately. And now it's going to go into cut. Another thing that I want to do while this is going is, like I mentioned earlier, there's going to be a taper in this particular airfoil. The cord length that I'm cutting out here will be a function of how far over I have placed my foam block. So ideally, I mentioned earlier that 253.95 millimeters is the distance I want from the carriage to the foam. And so here, if I come and look at it, I am over 30 centimeters. So that's 300 millimeters. So I'm going to be somewhere in the middle of my foam block for this. That's okay for a test run like this. Just know that if your cord doesn't come out at the length that you expect it to, that is the reason why. And ideally, I would have actually probably moved that over to both the root, maybe done a second test simultaneously at my tip, so I get a sense for, as both of those are cutting, that I know what those lengths are going to be. So if any time while we're doing this cut, it's going to hit the weights or it's going to cut anything else, what we want to do is remember that we want to turn off the wire and stop the foam cutters from moving as simultaneously as we can. So as that's finishing out, cutting out the leading edge of our airfoil, I'm going to come back over here and pretend like this is an emergency to say for some reason we need to stop, and I want to hit stop on here to make sure that stops moving, and so it doesn't start dragging a cold wire through the foam. But if I leave the wire on for too long, it's going to cut a big old hole, which frankly, if it's an emergency and you're stopping for some reason, you're probably ruining your part anyways. It's hard to start it up once you've stopped it. And so your part, you're probably going to have to get a new sheet of foam, which is why we do these tests. You don't want to waste a nice big wide piece of foam first. We want to make sure to turn that off. Turning that off, again, will allow it to stop cutting and it won't be a danger. However, the wire is still inside of our foam block over there, and so we need to get it out somehow. So what I'm going to do is actually turn the wire back on and very slowly lift it up out of the foam. Keeping in mind that I don't want to overstress the wire. So we're going to come back over here. Nope, the hot wire is on. I don't want to touch it. We're getting ready to it. I'm just going to slowly lift this up, keeping well clear of the wire. Before I do anything else, turn off the hot wire. So now that wire is off, we can come and take a look at our test, and although this airfoil did not cut all the way through, we had to stop it part way through, we can start to get a sense for what the length of my cord was right at that particular span, and what the surface finish is going to be. Note that the surface finish will be slightly different on these test sections as opposed to a full length, because the heat that's going into the wire is being dispersed over a smaller area as opposed to a larger length of foam. So if you start to getting darker purple, which is indicative of it's kind of burning the foam, or it's a wider curve, it's cutting out more material than you'd anticipate, that could be okay. For your entire foam length, it'll probably be a smaller hole that's cut and a better surface finish. But again, if you're dragging the wire through this type of a test section, you know you're going to be dragging your wire through the full length section, and so you want to make sure that you try to avoid that at all costs. Now that I've done those tests, as soon as I'm comfortable that both of those are working, I can go back and do the same thing where I rewind my G-code from the very beginning, use my arrow keys to try to bring the wire back to its original home position. And as soon as it's roughly in that position, I can click on the go to 0 to have it center itself back exactly where we started. Then I'm making sure that through all this process we're being safe and the heat to the wires turned off. Now that that's all set up, I've convinced myself that this cut will be good and that we'll get the geometry that we want. So I'm ready to actually cut out my wing. For this last cut, we get our nice big block of foam, which either can be cut to the panel length that you want your wing to be set at, or it can be cut a little bit wider because we know that with a taper ratio, it's going to have a different heat setting from the root to the tip, because the tip, it's going to be moving around slower to cut that airfoil, whereas at the root it'll be cutting a larger airfoil. As it's moving slowly at the root, it's going to be cutting out more area, and our tip will actually be smaller than at the root. So oftentimes with a tapered wing, it's good to have a wider piece of foam, give yourself a bit of leeway on both sides, so that later on you can trim it down to where you know that your root is the chord length that you want, and you know that your tip is the tip length that you want. I'm going to set this on my block foam, on my sacrificial foam, line that up appropriately, keeping in mind my DX, which was the distance between the wire and where my foam needs to start. So my DX was 10 millimeters or 1 centimeter. So I'm going to make sure that's offset by 1 centimeter. My distance between the carriages and the foam block were equal on both sides at 253 millimeters. So I'm going to go ahead and make sure that I have at least that distance on both sides, which I do, plus a little bit of extra because this panel is too wide.